All right. Hello, everyone. Thank you for tuning in to today's installment of the Corundum developer meeting. So without further ado, let me go ahead and get into the status update slides that I have here. All right. So first up, announcements, then project ideas briefly, and then the status updates. All right. So announcements. The next Switch developer meeting will be next week on October 16th, and the next Corundum developer meeting will be in 2 weeks on the 23rd. All right. Product ideas. I'm not going to go over this in detail today. If anyone has any questions about this stuff, I would be more than happy to discuss it, afterwards in the discussion section. But the idea being, if anybody wants to sink their teeth into something in Corundum, here's a few ideas for potentially somewhat closed-ended features or project ideas. So feel free to bring it up in the discussion or contact me separately if any of this looks interesting to you. And I think I discussed some of the stuff more in detail in one of the previous ones, so you can watch the recording if you want to hear some more about these ideas. Okay, so getting on to the status updates. The main thing that we're working on recently is the new PTP subsystem and getting that kind of fleshed out and dialed in. So I'm going to talk about that in a little bit more detail. There's also been a couple of updates to the White Rabbit time sync ideas, and then also just another quick overview of some of the architectural changes that I'm thinking about for Corundum coming up. All right, so the new PTP subsystem that I'm working on here. So the idea, I've discussed this again previously in the last couple of meetings, but starting to narrow in on what this is going to look like here. So the idea is to distribute PTP time from the hardware clock to leaf clocks and do this with basically a one-wire serial protocol plus the PTP reference clock. Right now, the timestamps are the PTP time is distributed as a 96-bit wide parallel bus, which naturally that takes up a lot of logic resources. And if you got to cross SLRs, that's not so great. But if we have a one-wire serial link, then we can insert a bunch of pipeline registers or whatever, and we can run that a long distance across the device, and it's not taking up a lot of logic resources. It's a little bit easier to deal with. So the hardware clock module will generate this serial signal, and then we'll have leaf clock modules, which basically take that serial signal and can regenerate a PTP clock of a couple different formats. So you'll put those around the chip, say on all of the Ethernet MACs on the TX and RX side to provide the reference clocks or to provide the PTP clocks for the timestamping, and it's pretty straightforward. So basically, the leaf clocks will replace the PTP CDC logic that I currently have. And then once that is working, then the idea will be to extend that by supporting a truncated timestamp format. Probably, I'm thinking a 48-bit timestamp, 32.16 fixed point, which can then be extended to the full 96-bit timestamp when that information needs to be passed across to the host or used internally for whatever. And that means you save a lot of logic resources and all the buffering. Anything that's handling the timestamps is going to get a lot smaller. So the status at this point is that I think I have the protocol more or less figured out for the one-wire serial thing. I have a simulation model that I'm putting together that basically generates that data with the appropriate timing, and that's mostly done. I have a few tweaks to do and a few things to modify. There'll probably be a little bit of back and forth as I start writing the HDL and actually kind of getting this thing tested out. Right now, pretty much everything is, more or less just still conceptual. Got to put the pen to the paper, if you will, and get it sorted out. So as that happens, there'll probably be some modifications. And then I'm working on HDL for the leaf clock module. Once that looks pretty good, then I'll also write the PHC module, and then I'll try it out in hardware on Corundum, and we'll see how it works. And I think the path for that is going to be Pretty simple. We're going to replace basically the existing PTP CDC modules in the design with the leaf clocks. In the 96-bit format. We'll see how that works. Then we'll swap the leaf clocks out. Well, yeah, then we'll probably swap the leaf clocks out for the truncated versions, make sure that works. And then the idea is going to be to basically remove a lot of the CDC modules from the design, or the leaf clocks from the design itself. And then those can be instantiated alongside the Ethernet MAC modules or whatever in the appropriate clock domains. So that'll basically remove some of the common logic that's inside of the current Corundum design, and then that'll be implemented alongside the Macs or whatever, such that it'll be set up exactly as the Mac modules need it, basically. And then, yeah, so the Mac, you would have, eventually what I'll do is I'll have a wrapper for the Mac modules. And then you'll just have an input for this serial clock with the ref clock, and then internally it'll generate whatever timestamp formats are required. So that's kind of how things are looking at the moment. Here's a few more details on what that serial protocol is looking like. So I'm using a 16-bit UART-like protocol. So UART's like 1 start bit plus 8 data bits plus a stop bit, and it's generally running at a pretty low bit rate. But the idea with UART is usually asynchronous, but it doesn't have to be. So in this case, we're going to be using the PTP reference clock as the bit clock, basically. So the bit rate is going to be equal to the ref clock frequency, and instead of using 8 bits for the data, we're going to use 16 to get a little bit lower overhead, and no stop bits, again, to get lower overhead. So this means that it takes 17 clock cycles of the reference clock to transfer each word, and that means you also get 17 clock cycles until you get the next word to handle, transferring that across to a different clock domain. So that works out pretty nicely. With leaf clock modules that also have to do clock domain crossing, we don't need to jump through a bunch of additional hoops in order to transfer this information into the destination clock domain, which is useful. Now I'm thinking about using a kind of an update period of 256 clock cycles. Making this a power of 2 makes it relatively easy to have the PTP hardware clock basically jump. Instead of updating every clock cycle, you update every 256 clock cycles. You can just bit shift the period value when you add that in. So if we take this 256, we divide by 17 bits, you get 15.05. Subtract 1, round down, you can fit 14 16-bit words into each message. So every 256 cycles, you start sending a new message. And then there are, I think, exactly 18 bits then of idles between the two, which is perfect because that then allows the frame sync to work correctly, such that no matter where you start processing the data and attempting to extract the bits, you're guaranteed to get a lock properly on the next message, even if you started in the middle of the current message somewhere and the frame sync is out of whack. And then the idea is to do things kind of similar to how the GPS almanac works, where different pieces of data are sent at different rates. The messages that are sent, there's a certain piece of information that are going to be in every message, and then certain piece of information that are going to be in every, K messages. So you might have 3 different message types, and then you send those round robin style. So for a certain piece of information, you get one message, you have it. For other pieces of information, you might have to wait, 2, 3, 4 messages in order to get that. The priority that I had for putting this together is making sure that the 64-bit clock could be set as quickly as possible. So if we can include all the information necessary for setting that clock in every message, then that clock can be set and locked as quickly as possible coming out of a reset. and then everything else will, kind of figure itself out after a few more microseconds. So shouldn't really be that big of a deal. So the messages that are being sent, every message contains everything for the 64-bit clock. And then right now I have 3 message types basically that are defined, and those contain a combination of the information for setting a 96-bit clock as well as the information necessary to reconstruct the timestamps, basically going from the truncated format to the full 96-bit time of day timestamps. And to do that, I'm sending 2 different offsets, one for basically the current second, and then another one for an alternate second, which is either going to be the second before or the second after. And then update the alternate and swap the current and alternate slots at the appropriate times to make sure that you always have about a minimum 500 millisecond window over which you can, minimum plus or minus 500 milliseconds over which you can reconstruct timestamps. So basically the idea is that when you're going into the start of 1 second, the alternate offset is the previous second. And then in the middle of the current second, then you would update the alternate to the next second. So you go from having a second and a half before to a second and a half after. And then, I guess you don't have to update right in the middle. You could update later, and then you can have more previous window. So you can skew it a little bit without too much difficulty. And then when you get to the end of the current second, then you swap them. The alternate becomes the current, and then you continue on. So that's kind of the idea. And potentially the modules that are actually performing the reconstruction can store some additional history if you want to extend that window into the past more. So that's kind of what this is looking like at the moment. And again, the current status on this is that I have a simulation model put together for generating this serial protocol, and I'm working on getting the leaf clock operational in HDL. All right. And then that brings me to the White Rabbit time sync stuff. And basically, with the original White Rabbit switch design, they run everything at 125 megahertz, which is synchronous. So all of the Ethernet transmit clocks are all synchronous with the same 125 megahertz ref clock. So the only thing that they need to do really is measure the phase offset on the RX. I guess there's a few other tricks that they might need to play in terms of the transceivers and resetting things until they get the appropriate phase offsets and whatnot. But yeah, by running everything at 125 megahertz at the same clock frequency, that means that all you need to do is phase measurements with the DDMTD. But for Corundum, we have multiple different clock frequencies involved. At least 161, 322, and 402, depending on how the transceivers are configured and what rates you're running at. These are not so nice numbers, but they are related with integer ratios. They are also related to 125 as well, but it's that's a less nice ratio. So originally I was thinking, well, maybe what we have to do is use kind of the lowest common clock frequency here and then divide things down. But I guess there has been some work done on a relatively straightforward modification of DDMTD that adds some periodic clock enables to the input and output side. And the idea is it works kind of sort of similar to how you would have the phase and frequency detector in a PLL, and you'll divide the input reference and the feedback clock by different amounts to get the appropriate multiplication ratio, because the frequencies will match going into the phase and frequency detector due to how the PLL works. So the DDMTD, the idea is you could do something quite similar, where you can basically divide down both the input clock and the output clock, or the two clocks that you're comparing, by different integer division factors. It might be limited to even factors only. Not 100% sure about that. That could be the case though. But that means that if we can use that approach, then we don't actually have to run 40 megahertz ref clock. We could leave that at 161 or 322, something like that, to get a faster update rate for these messages that get sent periodically, for making sure all the clocks are locked and will lock quickly when coming out of reset. But then we can still support all of the different clock frequencies that we need, because the idea is that you would basically be dividing both the input and the output by the appropriate factor to get the frequencies to match. I guess there's still the question about how to handle the 250 megahertz PCIe clock in PTM. If we're not using PTM, it doesn't really make that much difference. If we are using PTM, obviously you want to be as accurate as possible. So I'm not sure the best way of handling that, because that's definitely not going to be, you're not going to synchronize that and run it at the same frequency in the same phase. So not sure about how to handle that at the moment, but we'll cross that bridge when we get there, I think. And then that brings me to the architectural changes that I've been planning on, and these are a little bit more discussion points than anything else, because I discussed these previously in the last couple of meetings. The first one is a single hardware interface. So the idea is that Corundum right now supports multiple interfaces in hardware, and each interface contains its own set of queue management logic and whatnot. But with some of the modifications that have been implemented Corundum recently, in terms of improving the queue management logic, improving some of the RX queue selection, so not so much RSS, but the indirection table, the implementation of that sort of thing. It's getting to the point where software can basically subdivide one hardware interface into multiple separate software interfaces. So what we can do is move the design in the direction of having a single block of logic for managing all the interfaces, or for managing all the queues and whatnot, that's shared across all of the ports. And this is definitely going to be a significant advantage for smaller FPGAs, where you don't have all that many logic resources, because having all of these additional copies of all of the queue logic is not very efficient from a resource utilization perspective. So cutting all that down, I think, is going to end up being a significant advantage. And it's definitely something that I'm going to be looking into here. I'm not sure about everything that needs to be adjusted for this to work. I'm thinking mainly we're going to have to fix up some, let's see. So I guess there's a couple things. One of them, the queue management logic needs to be, or not the queue management logic, the FIFO logic needs to be reworked a little bit. And then I also need to get some of the internal flow control operational. This was something I think I discussed quite some time ago, but that needs to be revisited. And it might also make sense to rework the scheduler logic a little bit as well, because I don't think it makes sense to have one scheduler per port if we can potentially set up one scheduler to, work with multiple ports at the same time. So I think some combination of all of that will have to be implemented before we can try to move things over to this setup. But if we can implement all that, then what we should be able to do is, for designs that run at 25G and have QSFP interfaces, for example, we should be able to turn on all of the individual lanes without using a silly amount of logic resources. So that means if you take an Alveo board, you would have eight ports. If you have one of the boards with 4 QSFPs, you'd have 16 network interfaces showing up at the OS level. So that could be interesting. And I think this is also going to be super useful when we have the embedded switch operational. All right. And then another component that I'm still getting my head wrapped around is what is going to need to be done when we integrate the switch into Corundum, mainly in terms of clocking and the application section interface. So if we're going to put the switch on there, then we got to think about things like handling port splitting, right? 100 gig port versus 425 gig ports. What are we doing with the the Mac level interfaces, AXI stream interfaces at the application section? Are we actually going to provide two sets, one for 100 gig, one for 25 gig? Are we just going to have one set that's basically the 100 gig interfaces, but that will carry the aggregate data across the multiple internal ports for 25 gig? Not sure. It's also a question of clocking. Is anything going to have to change in terms of, what these, how the port split interfaces work, but also how things might work once we have the switch sitting in there, right? Because the switch has its own internal clock domains as well. So it might make sense to look into potentially even decoupling the Corundum core clock from PCIe and running it synchronous to the switch clock, which could open up some interesting possibilities in terms of running it either faster or slower than the PCIe clock. Some other stuff to think about a little bit. I mean, I think right now for a lot of parts, it's hard enough to close timing at 250. If you're going to run it faster, you could run into issues. But I know there's definitely some cases where running it a bit slower would definitely help things. Right? If you're on 200 megahertz or something, instead of having to adjust the PCIe IP core to run it, Gen 2 or fewer lanes or something. So that could potentially be advantageous. That one in principle shouldn't be that big of a deal because it's just a matter of figuring out the clock domain crossing to the PCI Express hard IP core. But yeah, we'll see. Something else to think about. And then the last slide I have here for today is the application section pass-through. So the idea is that for certain applications, you're going to want to be able to pass through additional signals through to the application section from the top level. And I was thinking maybe this could be done with macros, but I think the folks at MLE might have come up with a couple of other ideas. I haven't had a chance to take a look at what they posted yet, but I think they have some ideas that they put up on the GitHub repository. And I don't know, I think Oscar, who's on here, might have been the one working on that, if I'm not mistaken. I don't know if Oscar wants to discuss what he's been doing at all. Not to put you on the spot. I think you might be, Oscar, if you want to say something, I think you might be muted. I can't hear anything.
All right. Okay. Yeah. No, it should be working. Yeah, that's me. I'm working on that.
It's usually Joachim with that mute problem.
Yeah.
Anyway.
Yeah, just yeah, I didn't actually prepare right now to really talk about this in detail. I don't know if we have the time to look a bit into it now.
Yeah, we certainly could. I mean,
if there's
I don't have any other
nothing
status
else to
update
discuss
slides, so we might as well go into more detail if you've been the one working on it and you want to say a few words about the approaches that you've looked at, that would be cool. And I don't know if you want to share your screen or if you want me to try and pull up the GitHub page on my end.
You can maybe just pull up the GitHub issue and
right.
Yeah,
okay.
I can quickly give you an intro.
Yeah, one moment here. Gotta locate the right thing here. All right, issues.
And by the way, I'm sorry for being so anonymous. I don't have a webcam on me right now.
That's fine. That's fine.
Just have to be happy
when
with
you're
my
sharing
voice.
screens, it's You can't really see that anyway
That's true.
necessarily. All right, let
Yeah,
me.
speaking of not being able to see, I cannot see the contents of that screen. Oh, okay, no, it
Yeah,
was just an overlay.
I need to readjust something here. Yeah. All right, come on, Zoom. There we go. As with Zoom, you can share a single window, and that's what I usually do. Okay, there we go. Flip side is whenever you put another window over the top, then I think it like blacks it
Ah,
out.
yeah, yeah. I think that was
All
a.
right. Can I make this a little bigger? There we go.
Okay, actually, I just see that there is a little bit of a fuck up with the formatting. Should fix that.
Okay.
Oh yeah, well, that wasn't smart to use the accents there. But anyways, yeah. So right now I only just prepared three very simple examples. So I didn't actually implement this in the Corundum code base yet, because it's
Right.
just about being able to discuss the approach from a principal perspective. And I'm not sure if you can look at these without any issues. I don't know if you have an EDA Playground
That one's
account.
asking for login. This one,
That's weird. Let me check
I
that.
don't know why one of them needs a login, but not the other one.
Yeah, it
Hmm.
might just be my bad configuration. I'm gonna fix that right now in 1 second.
Yeah, okay. But this one, okay. All right. So in this case,
But
we have
yeah,
the
basically.
defines. And so this one, let's see here.
Yeah, so this is I don't know if you want to just look into it in silence or if I should comment on that, but
Yeah, I'm just looking at, I'm kind of digesting what's here. If you want to comment on it, that's great. That works.
yeah, so this is the more complicated approach, and honestly, I'm not sure if that's even worth considering, because let me start with that seems not to work with all the tools. So it
Hmm.
does work with Vivado. It works with I think one of the commercial simulators that are available at EDA Playground, but with the others it doesn't work, and it seems like there is no no consistency among the simulators how these nested macros are evaluated. So some of them fail with that, because this is like the idea here is to just define the list of ports once, and then everything is substituted by the macro as it's needed. So you can define the list of signals once, and then it's used as for the port declaration as well as the port mapping and everything else you might need. So I was feeling like that would be nice because it reduces the redundancy, but on the other hand, like I said, it doesn't work with all the simulators. So I guess that's not really a valuable option.
Right. Yeah. Hmm.
But I still wanted to just include that because I don't know what the stance of yours is on like how we want or how compatible we want to stay with everything that's around. Like, but I guess it's always a good idea to be
Well, I
compatible with
mean,
as
the
many
big
tools as
thing
possible.
is that it needs to work in Icarus Verilog and Verilator. And if it works in those, then I'm
Mm.
pretty happy. If it doesn't work in all the commercial simulators, I mean, well, um, yeah. So I don't
But
know.
it
Have
does
you did
work in Icarus Verilog actually.
It does work in Icarus Verilog?
You
Okay,
can
well that's
even
good.
launch the simulation if you want right now, I guess. It's just
Yeah,
very
I'm not.
quick test
Well,
launch.
let me see. Did you change anything? Well, I guess I can't log into that. I
No, I
guess I
got
need to go
lost
try to
in the
reopen this here.
discussion. Give me 1 second.
Oh, I guess there should actually be a third one here. All right. Eh,
It's funny because that didn't show up in the preview, the issue with the formatting there. Let me check.
none that my copy didn't work, right?
I'm not logged in yet.
Yeah, I was just looking at that what you posted there, and I obviously. Oh, now all these are showing up. Interesting. All right, so let me get these back in order. And I was trying to think, how do you even fix the formatting here, right? With your little backtick. Well, you usually use the backtick for formatting this stuff. Okay, so I'm not sure offhand the proper solution for that. Like, how do you
Give me one
do
second.
in GitHub? How do you format code with a backtick in it? There's got
That's a
to be a
good
way to do that.
question. Yeah, I'm just gonna leave out the backticks for now because we don't really need them. But
Yeah,
not in the posting at least. So now it's updated, and now let me just check the access
oh,
rights.
I was gonna hit refresh, but it refreshed it already. Okay, that works. Anyway,
Okay,
it looks like
so the
they're
examples
all
should all
working
be
now. So
public.
yeah,
They're all working now? Okay.
yeah. No, I reopened it and now it looks good. So okay, okay. So all right. So we got three different ideas here. So the first one, I guess the first one was kind of my idea in terms of, hey, let's use include files, which
Yeah, that's right.
works, but okay, yeah, we got to do everything, four times, and you got four different files. So, all right, it works, but okay. But then the second idea is, I guess, basically the same thing, but we're just defining these various macros, which then get substituted. So because we're defining the macros, you can do all that in one file. You don't need multiple files.
Yeah, that's
Um,
right.
so yeah, from that standpoint, I like it. That's better. And you can potentially have even more stuff that's defined in here as well. So, um, and then you've got the cross hierarchy port ones, which, I mean, hmm. Yeah. So you're saying that the issue with this is how they handle the nested macros.
Yeah, that's
Um,
right.
So I guess Oscar, the question basically is, and I'm not even sure if this would work in the C pre-compiler preprocessor, in kind of having a kind of a function argument as an argument to a function like macro here. So did we look at the spec, if the spec says anything about that?
Well, yeah, Ulrich and I looked into it, and it was. I think it's a question of how you interpret it. Like,
Okay.
I don't know, Ulrich, maybe you want to add into that discussion, but it seems like the language reference manual isn't exactly precise about that.
Yeah, I think it comes down to the order of uh yeah, execution, right? And that's not exactly specified. You could read something like, hmm, what was the conclusion we could read out of out to inner,
Yeah, exactly.
but it is not exactly clarified. So there is no precise um, rule like if there is a macro in a macro, you have to do it in a certain way.
in the simulators where it doesn't work, what happens? Is it like a syntax error or something, or does it just not do the expected thing?
Yeah, it's just a syntax error. At least
I see.
for the ones I tried, it was always just some kind of syntax error, some kind of obscure and syntax error, obviously, because it was just
Because it's
resolved
not
very
because it's not
weirdly.
expanding the macros correctly, right? Yeah, okay.
Yeah.
Hmm.
I mean, honestly, the other approach, like the second approach, the one where you have not multiple files but just one defined file with a bit of redundancy, but well, that's fine. I guess it would make sense anyway to have these auto-generated. If I mean, I think it's quite trivial to do that. Only question is how you define the list of ports then. But I saw you also have like other small code generators for like generating wrappers around some axis stream components and everything like that, which I think is quite convenient. And maybe a similar approach would be suitable here to avoid like typing out all of this by hand and making a mistake somewhere. I mean, you
Right.
always have the issue of having to type this out by hand, but I guess it's nice to avoid it as much as possible.
Right. Well, I definitely so I definitely think we can throw out the first one if we have this second one, which puts everything in one file. So I don't think there's
Yeah.
really any. The first one is just like, well, yeah, okay, you can do it that way, but I guess you don't. If you can do it with just substituting, that's going to be a little bit cleaner. Um, right. Yeah, I'm just wondering if if you can kind of implement this third idea with the same, integrated code, right, as you have for the second idea here, right? So we have these specific defines. Well, could you use those same defines here, and just add some, basically you'd be moving your, this part of it where you're doing this substitution to the bottom of this.
Oh yeah, that
these
makes
guys.
sense.
Basically, right? Or I guess you'd be moving these two down here, to generate these guys. So that, I don't know if that would really change much of anything, but that I guess would give you the option of basically doing either of these. So if you're only using simulators where where this works, and this works with all your tools, then you can use that approach. Otherwise, then you can go to using this slightly more redundant approach, but more compatible approach. That might be
sense,
a reasonable trade-off, because the main thing is to figure out what things need to look like here, right? Well, what code we need to incorporate into Corundum itself, and pass through all the modules. So if we can keep that same and support basically both of these techniques for setting everything up, I think that could be pretty optimal.
Yeah, that makes sense. I'll check out whether it's feasible to just. I guess that shouldn't be much of an issue just to.
Yeah, it seems like it would just be a matter of adding a couple more defines down here. But
yeah, that's right. That's right. Probably not gonna solve the simulator issue, but you have a good point there. I'm gonna try that.
Well, that's great. That's great. Really good progress there. So we'll have to see if we can put the finishing touches on that. Then we might be able to get that merged in relatively soon, so you guys can start taking advantage of it. I think I've had a couple other people ask for similar questions, or ask a similar question: how do we add additional stuff? But yeah, that'll be a pretty good feature to have. All right. Well, great. Thank you very much, Oscar.
Yeah, thank you.
Anything else that people want to discuss? MLE or otherwise, as the case may be? I guess not. All right. Well, I guess we are a little bit under time. We could end now, or I could also take the cover off of this optical switch that I've been screwing around with, if you guys want to see the inside of a 16 by 16 beam steering optical switch. That doesn't sound interesting. All right. Fair enough.
Me, yes, Alex. I would like to.
Oh, you want to see it? All right. All right. Let me see about see if I can. My camera here is going to cooperate. I will go ahead and this is what I've been screwing around with all week here, basically. Let me see. Can I just switch this over to, is that the one? All right, there we go. So this thing, it's a Pilatus 16 by 16 optical switch, and let's see, the one that I ended up getting, it seems to be like some sort of a unit that was used for some sort of testing during production. It was outfitted with, or at least it seemed like at some point it was outfitted with a bunch of temperature sensors, but it was never fully assembled. So, there's nothing connected up to the LC connectors on the output. and everything coming off of the switch is just bare pigtail fiber. So yeah, originally I was thinking, oh, maybe we just need to terminate all the fibers and then it'll work. But it seems like the switch itself needs to be calibrated or something. So yeah, in the process of trying to figure out how to do that, I opened up the actual switch module. After exhausting all of the possibilities of looking at the main controller firmware, this is what the I have to result actually looking at what's going on inside of the switch. So this is what the switch looks like here. So we got the driver board over here. You can see Pilatus. Over here we got a big honking power supply. The interesting thing is that this uses piezoelectric drives. And from looking at this power supply and the fact they have, insulating stuff on top of it, I was thinking, they must be running at like 50, 60, 70 volts, something like that. But no, it's only running at 15 volts. So that's a bit of a head scratcher. I'm not sure if that's an issue or not, or if there's something else going on. I'm thinking it just needs some calibration. But yeah, over here we have the actual switching modules. In fact, let me just take this little plate off real quick so we can get a view of what the actual actuators look like. Yep. So they use these long piezoelectric actuators here, and then at the end there's a little linkage that connects it to the little collimator. So each one of these little ceramic boards has 4 of these actuators on here. And there's a stack of 4 here, and then there's a stack of 4 over here. I guess you can see the ends. So all of the, I guess we're not seeing the actual fibers. We're seeing these little metal dividers. So there's some sort of a feedback setup they have here for adjusting the position. I don't know exactly how they're doing the detection. It might be some sort of capacitive thing, which would explain the the metal dividers in the middle. So they use that to detect the position of the little fiber of the collimator lenses, and then they have a DSP chip over here, which I guess is looking at that information and then adjusting the drive signals going to all of the actuators here. So there's not a whole lot to see, but it is a pretty cool looking unit. Although look at all of the transistors over here on the drive port for driving the actual piezoelectric actuators. This is just for one side of it. There's a whole bunch more on the other side here. I don't think I can get it quite close enough to the camera to see that. Let me see if I can zoom in on these actuators a little bit. But go like that. That's a little better. Now you can get a better picture of what's going on there. So yeah, I haven't been able to find any pictures of the internals of these things online. So this could be the first time somebody's taken the top off one of these. Pretty cool looking units. Hopefully I'll be able to get it working, but we'll see. The other thing I noticed as well is that I thought this was a single mode switch, but after getting the fibers cleaved and put into a couple of fiber adapters, they appear to be multi-mode fiber. So I guess that means this is actually a multi-mode switch. So I'm not sure if it's even going to work for the single mode modules that I have, even if I do get everything working and get stuff terminated and whatnot. The other thing I never realized until recently is that you can actually get fusion splicers new for like $600. It's crazy. I thought they were like 10 or 20 grand, something like that. So that brings that into the realm of possibility of actually getting access to one of those to terminate all these fibers with proper connectors. The other thing that I learned is that apparently you can get other fiber handling tools just off of Amazon. Like seriously, you can get a fiber cleaver for like $25. So okay, that works. So yeah, I got that and the the fiber adapters off of Amazon for hooking this thing up and just, seeing if there's any signs of life. And unfortunately, there was some, but it's like if you take port 1 to port 17, which is just kind of 1 to 1 through the switch, that works. But if I take 1 to 18, the insertion loss goes up by a lot. If I go 1 to 19, there's like no light going through at all. So, yeah, I got to figure out how to basically adjust the position of these, collimator lenses in this thing, for all of the switch configurations effectively, in order to get the proper amount of power. I suspect maybe what the story is with this is that they don't actually calibrate the thing until they actually assemble the whole switch and terminate all the front panel connectors and whatnot. So because this one was a production test unit where it was only partially assembled, they just haven't run the calibration routine. So that puts me in the situation of, well, I got to figure out how to perform this calibration operation with something that's totally undocumented. So yeah, not sure how that's going to work, but I'm going to chip away at that, and we'll see. Anyway, that's about all I got for today.
Very interesting.
Hopefully
also,
that was interesting for somebody.
Yeah, very interesting and also very nice work from you, yeah, to figure out all those things.
Yeah, it's always fun taking apart some of these commercial devices and seeing what's in there. I think I'll have to show this to Max at UCSD, who is our optical switching guy. He'd probably be very interested in how this thing is put together.
Sure.
All right, so is there anything else that we need to discuss for the meeting today, or is everybody good to go?
For me, it is fine.
Okay, no major updates on the Switch that need to be discussed, or it can wait until next week, I guess.
Yeah, we can say some things for Monday, yeah, for next Monday.
Yeah, all right, sounds good. All right, well, if we don't have anything else to talk about, then I guess we'll go ahead and adjourn for today then. All right, thanks to everyone for tuning in. Thanks to Oscar for talking about the stuff he's been working on. Yeah, well, we'll talk to you guys next week or in 2 weeks, depending on whether or not you're interested in the Switch. All right.
See you. Thank you.
Thank you. Bye-bye.